Hi, Assalamualaikum. So our group today will present about fundamental of airflows. First of all, I would like to introduce my group members. So our group consists of 7 people, which is me, Muhammad AIMAN bin RAZAK, Wang Chunwai, HAZRIQ HAKIM, HARISHWAR, Jeremiah DARSHAN, Muhammad FARIS ATIQ, and Haris ANAK Smail. So I will give an explanation about friction chart, or also known as duct friction loss chart or duct sizing chart. So it's a graphical tool used in HVAC design to estimate the pressure drop or frictional losses in ducts of various sizes and configurations. It helps engineers and HVAC professionals to determine the appropriate duct size for a given airflow rate, taking into account the expected frictional loss. So this is an example on how to use friction chart. Well, first of all, from the friction chart, it shows from the vertical line, it shows the air quantity or air flow rates, and the horizontal line will represent the friction loss. From this line, you can get the size, duct diameter in inches, and this line will tell you about the velocity for the system. So let's say the airflow rate given is 6000 CFM and the duct size is 28 inch. So just draw a vertical line and draw a line with this angle, and when the line is intersect with each other, just from the point, just drag and draw a horizontal line to the left, and from that you get the friction loss is 0.08 inch of water per 100 feet. And if you want to find the velocity, just draw a line with some angle, and from that you will get the velocity in the system will be 1400 feet per minute. So the effect of friction in duct flows primarily manifests as pressure drop and reduced airflows. Next is altitude effects. So the air pressures, at higher altitudes, the atmospheric pressure decreases. This reduction in pressure affects of the performance of mechanical equipment, including fans, compressors, and combustion system. Equipment selection and sizing should be considered the lower air pressure conditions to ensure proper operations and efficiency.
Hello, my name is HARISWAR and I will be presenting for the assignment for the air distribution units. For our topic, the theme one is fundamental of airflow. Now, I will explain about the duct calculator. A duct calculator is a tool used by hatchback professionals to calculate the size and airflow characteristic of a duct in a ventilation system. It helps in designing and sizing ductwork to ensure proper airflow, efficient operation of hatchback system. Now, we will proceed to the altitude effect. For the altitude effect, at a higher altitude, the atmospheric pressure decreases. Thus, this will reduce the pressure effect of the performance of mechanical equipment, including fans, compressor, combustion unit, and equipment selection and sizing should be considered to lower the air pressure regulation to ensure proper operation efficiency. Now we proceed to the density effect. For the density effect, airflow and duct sizing, density effect the airflow characteristic within ductwork. This means higher density increase the mass flow rate of the flow rate, which can impact the selection of duct size and design of the distribution system. Duct sizing calculation should account for the density changes due to temperature and altitude variation. And for the friction chart and effect of friction will be further explained by my next teammates. And we'll proceed to the next slide for the altitude effect for further explanation. Now, on this slide, I will presenting about the altitude effects for the airflow. Now, altitude is a vertical distance between object on the mean sea level. And how does altitude affect the climate? Area of, at high elevation or altitude have a lower temperature than area at a low elevation. This explains why Baguio has a colder climate other than place in Luzon. Baguio city stands for 1,435 meters above sea level. Now we will explain for the why does the pressure drop at a high altitude? When you pressurize air or any gas, it gets hotter. When you release the pressure on air, it gets colder. Lower pressure at a high altitude causes the temperature to be colder on top of a mountain than at sea level. Then thus, the higher the altitude, the colder the temperature. And now I proceed to the next slide for the density effects on the airflow. For the density effect, on heating and before the heating capacity, the density of air affects the heat transfer capability of HVAC system. The system relies on the transferring heat from a heat source to the air. By cooling the system, extract heat from air, changes in air density can impact the efficiency and effectiveness of this heat transfer process. For example, the higher altitude where air density is lower, heating system may need to work harder to achieve the desired temperature, while cooling system may improve performance due to lower heat capacity of the air. And you can see from the picture diagram how the temperature affect density. When increase the heat of the object, the density of the object will become separate. Will thus they mean that as the temperature increase, density will decrease. Proceed to the question and for the next slide.
Very good day, sir. My name is HARISHWAR. My registered number is D0920100368. So today I'm going to explain about the question. Question number 1. What factors should be considered in the design of HVAC ducting system for optimal airflow distribution in a commercial building? The design of HVAC ducting system for optimal airflow distribution in commercial buildings requires consideration of several factors, which is duct sizing. So as a duct sizing, determining appropriate size and dimension of air ducts. For duct routing process of planning and designing the path that air ducts will throughout a building, take the air throughout the building. So for duct insulation process of applying insulation materials to the surface of the HVAC duct work. Insulation most important to maintain the temperature maintain the indoor temperature. The next is air distribution devices. Air distribution devices used in HVAC system to control the system and direct the flow of conditioned air into the indoor spaces. So these are the factors which we should consider in the designing of HVAC ducting. So that's all from me, sir. Thank you.
Assalamualaikum and hi, my name is HAZRIQ Hakim, and today I'm going to talk about the question for the airflow properties, or what we call fundamental of airflow. So my question is, what is the function of the duct calculator? So duct calculator is a tool used to determine the round duct size, shape, and convert it to rectangular or square size. Once is it known at least two parameters value, such as air quantity or cubic feet per minute, or airflow rate, and air velocity feet per minute, or friction loss and air quantity CFM or airflow rate cubic feet per minute. Proper duct sizing ensure efficient airflow and minimize the pressure losses. So, what is the function of the duct calculator is to determine the size of duct so that the airflow can flow properly to the determined area. Why is it important we use the duct calculator? Why is it important that we to determine the perfect shape or perfect size for the ducting system? So to first of all, to ensure the proper airflow. Second, to optimize the efficiency of the system. Third, is to make sure there is no energy losses during the airflow from the air handling unit to the determined or to the specific place. That's all from me. Thank you.
I am here to talk about Team 2, air distribution system components. First thing first is a system overview. Is to determine proper static and dynamic pressure in the ductwork and the size of the duct before choosing the right fan to provide the system flow rate. To achieve a proper ADS design, airflow principle should be taken into greater consideration. So first thing first, we have air handling unit. It consists of a fan, heating and cooling coil, air control, damper, filter, silencer, and a vibration isolator. They are all components of the air handling units. It's often used together and combine outside air that return from the building space. The air mixture is then heated or cooled before releasing into the building. So the constant volume and a variable volume is the two different type of AHU. They're exists in the air distribution system. So the constant volume is to operate at a constant airflow rate. The temperature varies to maintain the zone set point. So the variable volume, the supply air fan is operated to keep the ductwork static pressure at a certain level. So there's a lot of types of duct, which is galvanized mild steel, fiberglass, or fabric duct. It is to deliver air and remove the air by using the duct. So the control, the supply air temperature, mixed air temperature, humidity, and air quality can be all controlled through the control. The sensor for measuring temperature, humidity, everything, it is used to control that. So the next thing is to talk about the air distribution device. Usually, number one, a fan is used to create airflow by removing or supplying the air. Second thing is heat and cooling coil. It uses a system tube to circulate hot or cold fluid to transfer the desired thermal energy in the air. So the next thing is damper. It is to adjust the size of opening or passage in the HAZRIQ system. It's to control and regulate the airflow. Next thing is diffuser. The air is diffused and dispensed in very direction. It depends on which diffuser you're using. So the next thing is filter. It's designed to clean up airborne impurities like dust, pollen, and debris. It's used to enhance the air quality and shield the system part from harm. The next thing is silencer. It used to lessen the noise caused by air or gas movement or vibration. Vibration isolator. It is used to isolate the damping, the transmission of the vibration. The device or material can eliminate the vibration and noise.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad Faris bin AZHAR. I will lead my group discussion for the questions for our group assignment Fundamental of Airflow. The questions are: how does an air handling unit contributes to the overall functioning of an air distribution system? The answer is an air handling units play a crucial role in overall functioning of an air distribution system. It is a device that circulates and conditions air within a building. Typically, as a part of the heating, ventilation, and air conditioning HVAC system, the primary function of an AHU is to regulate the temperature, humidity, and quality of air in a space. That's all for the question 1.
Very good day. My name is DARSHAN, and today I'm going to present on the question number 2 for fundamental of airflow. So what is the different types of air distribution devices used in HVAC system based on the design and functionality? So there are 3. The first is grills and registers. So the grills and registers are used as the openings for the ducts and serve as an entry or exit point for the AC. Grills have fixed blades, while the registers have adjustable blades that allow the control of the flow. For number 2 is variable air volume or VAV. This is connected to the main ductwork of the supply, and the VAV box incorporates dampers that can modulate the airflow based on the temperature, pressure, or occupancy. For number 3, it is diffusers. Diffusers is used to distribute the airflow into an enclosed room. They are typically located at the ceilings or walls, which are designed to diffuse the airflow in various directions. Diffusers can be in different shapes, such as in square, round, or linear, and they may have incorporate adjustable fins to control the direction and pattern of airflow. That is all from me. Thank you.